All right, hello and welcome. Of course, today we'll be looking at bending stresses. So the first question on bending stress states that two plates 16 mm thick are joined by a double riveted lap joint as shown below. Of course, the thickness of the plate is 16 mm. The rivets are 25 mm in diameter. Of course, you can see our diameter here is equal to 25 mm. Now we have to find the crushing stress induced between the plates and the rivets if the maximum tensile load on the joint is 45 kN. So first thing, I will be bringing out the data from this question. So let's say data is given. So the first thing we have here is a thickness of 16 mm. So thickness T is equal to 16 mm. What do we have next? I have a diameter of 25 mm. So my diameter D is equal to what? 25 mm. What do I have next? I have a maximum tensile load of what? Of 45 kN. So I have P to be equal to 45 times 10 to the power of 3 Newton. Now, how do I get the crushing stress induced between the plate and the rivet? Now, when we are dealing with bending stress, the crushing stress induced between plate and rivet is nothing but what? It's nothing but load all over diameter multiplied by what? Multiplied by the thickness multiplied by what? The number of the rivet. Now, if you look here, we have two rivet joints here. So N, of course, N is the number of rivets. For this diagram, we have two rivets. So we have N to be equal to 2. So the formula, like I said, is nothing but what? Sigma C to be equal to P, which is the load, all over what? All over the diameter multiplied by the thickness multiplied by what? N. So this is what we have. So we know our value for P, we know our value for D, we know our value for T, and we also know our value for N. So we can substitute and get our crushing stress. So crushing stress sigma C is equal to 45 times 10 to the power of 3 all over 16 multiplied by what? Multiplied by 25 multiplied by 2. This implies that what? Our crushing stress will be equal to what? 60 Newton per millimeter square, or sigma C will be equal to 60 megapascal. Thank you for watching, and stay tuned for more videos.